Hello everyone. Today we are going to talk about properties of acids and bases. Bases also are called alkalis. Acids. We have talked about acids, about the reaction of metals with acids, and how hydrogen gas actually was produced. So now we are going to be more familiar about what acids are and more reactions about acids. By the way, all acids turn blue litmus into red. I'm going to show you a video how acids turn litmus paper into red. All acids taste sour. For example, when you drink orange juice, a lemon juice, anything which is soury, it has tangy, sharp taste. All of these are acids. Acids corrodes metals. Yes, when we were reacting acids with metals such as magnesium, we noticed that magnesium piece or ribbon, actually, all of it was corroded, becoming magnesium chloride with hydrochloric acid. All acids release hydrogen ions. When we were reacting acids with metals, we were splitting actually the acid into the ions that make it up. One of the ions actually was hydrogen ion. So all acids release hydrogen plus. Now, bases or alkalis, they turn litmus into blue, from red to blue. They taste bitter, they have bitter taste. They produce OH minus, which is hydroxide ion. You are familiar with hydroxide ion. We just talked a little bit about hydroxide when we were splitting water into the ions that make it up, hydrogen and hydroxide ion. Hydroxide ion is a negative compound ion. Feel slippery. Now, when we are going to talk about where bases are found and how are they used in our life, you will actually notice that really materials that have alkalis or bases in them, they feel like slippery feeling. Such as soaps, detergents, cleaners, household, all of these cleaners are made up of alkalis or bases. First of all, you have to know that strong acids and strong alkalis are caustic or corrosive. When we say corrosive, they eat your skin away. That's why we should deal with dilute acids or dilute alkalis. By the way, the caustic soda is an alkali which is very corrosive. So corrosive is a hazardous symbol that actually is shown on the bottles of acids or alkalis that are used especially in the labs. When they are not dilute, they are concentrated in order to warn you to be careful and to follow safety precautions when you deal with these substances. Okay, now let's move and talk about acids and bases and the pH scale. pH scale, as you notice, it is a scale graduated from 0 to 14. As you notice, from 0 to 14. Let's work it out here. Yes, it's from 0 to 14. The middle of 14 is 7. Now, as we go from 0 to 7, we have this area acidic, but we have less acidity. As we go further from 7 towards 0, we have more acidic substance according to the pH scale. By the way, pH scale measures the hydrogen ions that are released by substances. As we have more hydrogen ions, we have more acidic substances. So the more concentrated the acid is, the more hydrogen ions we have. So as we go further away from 7 to 0, we have more acidic, or we get more acidity. Now, if we go away from 7 but towards 14, now we have more alkaline or more basic substance. That means more corrosive, that contains more hydroxide ions. As we have more hydroxide ions, we have a stronger base or stronger alkali. At 7, we have a neutral substance. A neutral substance is neither acidic nor alkaline or nor basic. This substance actually contains the same number of ions, the same hydrogen ions. The number of hydrogen ions equals the number of hydroxide ions. When we have